Okay, so what is a force? You guys saw in during the prime time that forces are what? Pushes and pulls. So any push or pull. So in your notes on the left-hand side, your first key term is force. And then on the right, any push or pull. And what's up with the picture? What's the quote? What's the quote? Very good. May the force be with you. Who likes Star Wars? Who would consider themselves like Star Wars fans? All right. Well, Mrs. Myers, the other science teacher, is a huge Star Wars fan. In fact, they named their little boy Lucas. Yep. Okay. Now, do these forces right here look balanced? No. So again, a force is a push or a pull. Don't write this down. Now look, if you pay attention and you listen during notes, it's actually the less you have to write because I try to help you out a little bit. So forces can be balanced or unbalanced. In your notes, the next key term, on the left, write balanced forces. Next to that are equal in size and opposite in direction. Don't write anything else after that. We're going to go over balanced forces. And then in your notes, I want you to draw the two arrows. You don't have to draw them solid like mine. You can draw them like that. And let's give them a certain amount of force. So this one is going to be 10 newtons. And this one is also 10 newtons. So these two arrows, one's going that way and one's going this way. So they're opposite in direction. And are the two forces equal? Yes. So what happens is they cancel each other out. And the resulting force is what? 0 newtons. So that N, that's newtons. Newtons are used to measure force. So when forces are equal and opposite, this would be like playing tug of war. And the people on the other side are just as strong as you are. The forces are balanced and no one's going anywhere. Or if you've ever arm wrestled someone where you're stuck in the middle because both people have like the same strength and they can't get past each other. The forces are opposite. One person's pushing this way, the other person's pushing back, and they're equal. So nothing happens. Okay? Next in your notes, on the left, put unbalanced forces. And then put unbalanced forces are either not equal in size or they are not opposite in direction. The size of these arrows represents how strong they are. But when you draw them, you're going to see on one of your practice sheets that the length of the arrow represents the force. Okay, so your next two arrows that I want you to draw, make one of them 80 newtons. And let's make this one 20 newtons. I'm going to move out of the way in a second. I just have to write first, and then I can step back. Well, we're not writing the bottom yet because I'm not there. Stay with me, guys. I asked you to do the arrows right now. We're going to go over the arrows, and then we'll talk about the last one. Okay, are these opposite in direction? Yes, one's going to the right, one's going to the left. But are they equal in force? No, so if say you are say you are arm wrestling someone, this person is stronger than this person. By how much will this person win? 60 newtons. So the resulting force, the net force, the answer would be 60 newtons. Which direction? To the right. That would be the answer to a problem like that. Question? That's actually on the next slide. You're going to see what a newton is. Okay, so the net force, this is your next key term that goes on the left, is the resulting force. So these answers that we got, these are the net force. So the net force is the resulting force. It's when the forces are unbalanced, there is a net force. Because what was the net force when they were balanced? Let me hear you. 0, because they cancel. So what in the world is a newton? Next key term on the left, newtons. And then next to that, newtons are used to measure force. You're going to be measuring force in our activity that we get to do after all of this. So then after that, skip a line so it doesn't look like a humongous definition. And this is what 1 newton is. Okay, 1 newton is the amount of force that's required to give a 1 kilogram mass an acceleration of 1 meter per second per second. That's 1 meter per second every second. For 1 kilogram would require 1 newton. Okay, but what's a kilogram? What's kilo mean? 1,000. So a kilogram is actually 1,000 grams. So it takes 1 newton of force to move 1 kilogram 1 meter per second per second. Okay, so copy this down. This will make a little bit more sense after we've done a couple activities with it. I can go over that after this. Because if we have time, if we get far enough, I was going to see what your check on your groups again since so many people were absent yesterday. Are you ready? Let's go, guys. When you take notes, you can't just write super slow and nice and tidy. Sometimes you got to hurry up so that you don't get left behind. You're going to get those professors in college that just keep talking, don't give you any time, that they just expect you to keep up. All right, here we go. These are for practice. Let's look at the first one. I want you to make a new heading and call it force diagrams. And then we're going to start with this first one. So I want you to draw these two arrows, the first two, and put the amount of force each one is, yes, using. So what can you say about the direction of the two arrows? They are opposite. Are the forces equal? No. So what's going to happen? Raise your hand if you can tell me what's going to happen with this first diagram. Trey? There's going to be 30 newtons left over going which direction? To the right. I like that he said 30 newtons left over because there is some resistance pushing back, but it's not as much as this. So this side, the 60 newtons wins, but it wins by how much? It wins by 30 newtons, and it continues going that direction. So this would be the net force. And then when you're done with that one, draw the next two arrows. When Nevada gives you tests, like state tests, for example, your high school proficiency and the CRTs, you may see questions with these arrows. And you're supposed to understand them and know how to answer those questions. So it is important that you guys pay attention to this and ask questions if you don't understand. Okay, so look at these two arrows. Tell me about the direction. I want to hear everybody. They're opposite. What about the amount of force? They're equal and opposite. So what do they do to each other? And so what's the net force? 0 newtons. This is balanced. And then draw the next two arrows. Are those opposite in direction? No, those are two forces that are going the same way. So what do you think two forces will do that are going the same way? Maddie? They'll add up. They work together. So what's the resulting force? What's the net force? 40 newtons. And they continue going together. This would be like you're riding your bike and the wind is pushing you. Okay, so you're applying a force. You're riding your bike and the wind is adding on to the force that you are applying. And then look at the last one. The only difference between the last one is instead of left and right, it's what? Up and down. So you have opposite forces. Are they equal? No. Which one's greater? The one going up. So by how much? So the resulting force, the net force is 50 newtons. You can write up. You can draw an arrow going up. Those would be fine. Raise your hand if you feel comfortable with these. That is good. If you don't, make sure that you ask questions either now. If you don't want to ask now in front of everybody, that you come see me, email me, whatever you need to do. Okay, are you guys ready? Danny, sit up. All right, so we are not going to go over the types of forces yet. I want you to keep your notebook open. I am going to go over something first real quick. Okay, so when you ride your bike, your foot pushes against the pedal. The push makes the wheels of the bike move. When you drop something, it is pulled to the ground by gravity. A push or a pull is a force. So a good definition for force is a push or a pull in a particular direction. Forces affect how objects move. They may cause motion. They may also slow, stop, or change the direction of motion of an object that is already moving. So something can be moving and then a force can be applied to it. Okay? So forces can affect motion in several ways. They can make objects start moving, move faster, move slower, stop moving, change direction, or change shape. And when I say change shape, that would be like crushing a soda can. Okay? It takes a force to crush a soda can. All right? So in your notes, the next thing I want you to write is forces can make objects, right? Forces can make objects start moving, comma, move faster, comma, move slower, and you're going to finish listing these. Forces can make objects. You're going to list these. That should be better for some of you. So remember that acceleration is any change in velocity, and velocity is speed and direction. So anytime an object is changing its speed or direction, it's accelerating. So you can say, what I want you to write next is right here, forces cause acceleration. Do balanced forces cause acceleration? No. But unbalanced forces cause acceleration. It just didn't say that. So there's just a couple facts we might need to add. Not the first one because we already have it in our notes. The first one that we already have is forces are measured in newtons, so don't write that down again. But you need to put that forces act in pairs. There's an action force and a reaction force. Okay, so put that forces act in pairs. Put that forces act in a particular direction. Or you can put forces have direction instead of the particular part. Forces have direction. And they can't be seen, but their effects can. You can't see gravity, but you can see things fall. Remember when we talked about things that weren't matter? Gravity's not matter. It exists, but it doesn't have mass or take up space. Right, but we're not, like, you're the matter causing the force to happen, but it's referring to, like, natural forces like friction and gravity and, like, centripetal force. That's not light. That's heat. Not always. Okay, look at the next page that you have. Or look at the first page that you have, because this one you didn't have. I'm about to show it in a second. Okay, this page. What I want you to do is take about 2 or 3 minutes with the people you sit with, go through each picture, and you need to say whether the force is a push or a pull, and does it change the object's speed, direction, or both?